Hi, I'm Steven, and today I'm going to introduce my physics project. So, this is the poster that I made to introduce my project, and the title is Armor Piercing Shell. The armor piercing shell is a type of projectile designed to penetrate either body armor or vehicle armor. In this project, I will focus on the armor penetration, and my driving question is, how can we increase the penetration depth of an armor-piercing shell? And here are two tank models that I made. And this is a armor-piercing shell model. And I made these because um, uh, the tank is a type of thing that fires the armor-piercing shell and to penetrate the tank armor, but also the ship, the warships also can fire this type of shell. Then I will start introduce my PPT of the physics project. The title is Physics in Armor Penetration. First, what is a armor piercing shell? Just like what we said before, the armor piercing shell is a type of projectile designed to penetrate either the body armor or vehicle armor. From 1860s to 1950s, a major application of armor-piercing projectiles was defeated the thick armor carried on many warships and caused damage to their lightly armored interiors. But from 1920s onward, because the tanks were invented, the armor-piercing weapons are also required for anti-tank missions. Then on the right side, this is a graph of the armor-piercing shell. We also can see different part of the shell. Okay, so how does the AP shell that can fire from uh, the barrels? So the propellant exploded and create pressure on the AP shell, then pushes it out from the barrel. Then armor penetration. What is armor penetration? The process of armor penetration can be seen as the AP shell doing work on the armor, and the shell volume will replace the armor. Like in the right side, we can see when the AP shell contact with the armor, it pushes the armor and replace the armor. So the velocity and size of the AP shell are two important factors of the depth of penetration. Now I will going to talk about three ways that I found that we can increase the penetration depth. The first one is to increase the caliber of the gun. Um, Increasing the caliber of the gun, people can use a larger propellant that can create bigger pressure on the shell. Then the second one is increase mass of the AP shell. The third one is decrease the caliber of the AP shell while remain the momentum the same. So first, increasing the caliber of the gun. People can use a larger propellant, and the formula of the force created by the propellant is equals to P times S, where P is the intensity of pressure and S is the surface area. So when we increase the caliber of the gun, we increases the surface area, and which will create a bigger force on the shell. And with the bigger force, the velocity of the shell will also be increased. And from the kinetic energy formula, which is equals to half of the mv squared, the shell with bigger velocity will also have bigger kinetic energy. Therefore, when we increase the caliber of the gun, we can increase the armor penetration. The second way is to increase the mass of AP shell. We all know that velocity and mass are the two factors that can determine the momentum and kinetic energy. So when we increase the mass of the AP shell, we can obtain a bigger kinetic energy and a bigger momentum of the shell. The third way is to decrease the caliber of the AP shell. In the graph, there are two AP shells with different caliber but have the same kinetic energy. The shell with smaller caliber can penetrate more. This is because the amount of armor replaced by this shell will be smaller than the amount of armor replaced by the shell with bigger caliber. You see, it seems it contradicts with the point I previously made, which we have to increase the caliber of the gun. But actually, there is a kind of AP shell in this world which can achieve both points, which is called the APFSDS, armor piercing fin stabilized discarding sabot. Before we introduce APFSDS, let's watch a video first. The APFSDS is a kind of armor-piercing shell that's commonly used on main battle tanks. Uh, we know that momentum and kinetic energy are determined by mass and velocity, and the process of discarding sabot, like this process, it decreased the mass. Although it decreased a little mass, but allowed only the thin penetrator fired from a high caliber gun with a high velocity. Moreover, to maintain as much momentum as possible, the penetrator are usually long and heavy, made by depleted uranium or tungsten. This kind of armor-piercing shell met all three points that I proposed, which it can be fired from a high-caliber gun and have a heavy mass, and at last, when it reaches the target, only the thin penetrator will penetrate the armor. So the shell caliber is also small. At last, these are the references. Thank you.